Okay. So, so basically you did your MS at IISc, right? In
Yes.
1984.
Called ME in those days.
ME, right.
Which is MTech now.
Oh, yes, right. Now
Yeah,
it's
it
MTech.
used to call ME.
The same 2-year course, right?
First 1.5 years. So it
okay.
used to be 2 years.
Okay.
And then when the GATE exam started, at the beginning it was 1.5 years. And that was there for quite some time. And then it became 2 years again.
Okay.
So the first 1.5 year batch.
Okay. So the question is like, how does it feel to be back, like after all the time? How are your experiences?
It's always nostalgic, right? I have been back to IISc, but very short time. So 1 day, 2 days, give a seminar and go. But this time I spent quite longer time, right? Altogether maybe about 2 months, on and off.
Right.
So it's always a good feeling to get back.
Right.
Especially connecting with the newer faculty that they were not there in our time, right?
Right.
So getting to know them and how the department is progressing, campus has grown significantly. So this time I spend more time there, so I can walk around the campus, go around and see what are new, so it's always a good feeling.
Do you have any fond memories from?
Of course, lots of fond memories, but the situation was different in those days, right? For example, Google was not there. So the internet was very sparse connectivity that you can have. So email concept was not as prevalent, right? So I'll give you a very concrete example. So personal computing and networking was at the beginning stage. I'm talking about 84, right?
Right.
So that means that we had a mainframe computer. Computing center was just right here, but across the department, right? So you probably have no idea what it means. So we had the punch card. Right? You have seen probably the punch card, right? So you could just submit the deck, the mainframe in the mailboxes kind of stuff, and then they'll run it. Only very few interactive terminals were there. In the department, we had a VAX computer and PDP. And over there in the computing center upstairs, a few computers, and you would be getting as a master student 2 half-an-hour slot per week, and that you have to book a week before. It looks like antique, right? So the fun memory is what, right? That means, but you need more time, and that is for interactive debugging and everything, right? If you want to do something. So we used to come at 2 o'clock, 3 o'clock at night with the hope that some research scholars or PhD students or postdoctoral fellows, they'll not use their slots because their slots are given by some grants, and also somebody has to pay for it, right? And just sit there and wait there if some terminal is. So there are only 10 or 15 terminals in those days. Right? You can ask Professor Nadari, he was 1 year senior to us. We went through the same phases. So what I'm saying, that's a very fond memory. Just you come, take a nap, and then come at night 2 o'clock with the hope that somebody else will not use it. It was a different environment altogether, and we had a good time. So I was involved with the football. Right, I played for the university. So we represented IISc, went to Gulbarga, border of Karnataka and Maharashtra, to play, and we lost against the Mysore University 2-1. So those are fun memories. We went on train and had fun time, right? Yes. And academically, lots of interesting things. I mean, I can talk for hours and hours.
In fact, that is the next question. Like a time at IIT, how did it actually affect your current research interest? Like, for example, how was the first problem that you started? How did you branch out to where you are now? For example.
So I got my undergraduate degree from Calcutta University, BTech degree, and we were the first batch of computer science. Right? We were the first batch of GATE exam. We came here for 1.5 years. So we had a lot of
first batch of GATE.
GATE exam, yeah. So that's the time it started 1.5 years. But Professor Narori, they had 2 years masters. So they had the 2 years ME. So they graduated in June 1984. We graduated in December 1984 because the concurrent, right? So we had a lot of overlapping memory and courses and all. So the first one. So
technically was 6 months senior to you.
Yeah, because we had 1.5 years. They had the 2 years. Right. It was transition time. So 1984 actually we had 2 batches of ME, one in June, one in December, and then of course after that it is back to 1.5 years. Right? Is the cycle. So when I did my undergraduate, I had no idea I'll be doing masters, for example, right? But in my BTech project, I got interested in research. Then I saw the GATE exam was announced, and there's notice board, my Calcutta University notice board oh, this is a GATE exam. I said, okay, I'll just appear. So I appeared and got selected here. I'll ask you a quick question to you. So I took GATE exam in computer science, and I'm sure all of you probably have taken GATE exam, right? How many students take it now?
1,10,000 to be specific.
Oh, really?
1,10,000 in computer science.
I thought it would be 2 lakhs.
No, 2
And
lakh
somebody was
was
mentioning 5-6 lakhs.
No.
Whatever.
6 might be all of them.
Yeah, no, 10 lakhs, 9 to 10 lakhs, all of them.
Okay.
But I think computer science specific is 1,10,000.
1,10,000? Whatever.
Yeah.
How many students took it in the first year?
Yeah, 50 to 100.
Oh,
100.
just 100? I don't
Okay,
know.
that's your guess. What is your guess?
5,000.
Oh, you mean,
5,000. How many-
in your time?
Yeah,
The
the
first
first
batch of
batch.
GATE exam, how many students took the computer science GATE exam?
Oh, took the exam.
Yeah.
Maybe 500.
500? You said what?
1,000, 5,000.
5,000?
No, I think, yeah, like 250, 300 around. I don't know. I don't
I'm
think it will
assuming
be that.
publicity must have been less.
It's not just the publicity, 107.
170.
Because not many places they used to offer computer science BTech degree.
Oh.
Right.
Yeah, so publicity also maybe first year, but
Right.
but I think nevertheless the number of, so point I'm making, the situation was different. So, because very few places they had the BTech degree. MTech, ME was there. For example, here ME degree was there, but I can't get it. So anyway, so point I'm making, so I was selected for some job campus interviews and all after my BTech, right? So but then this GATE exam was there, so I was invited to come over here for, you know how the process is, right?
Right.
But then I got excited also, I just joined.
Okay.
So I was here, but I had no idea that I'll be doing PhD. Because I did not have any concept, but when I did my master's thesis over here, so that was, I think, a very instrumental. It was 1.5 years, but
Who were you under?
Professor Patnaik, you know
okay.
him?
Ellen Patnaik.
Patnaik, yeah. But I think that experience was very good. The reason I'm saying that I was also working very closely with a PhD student, and we together wrote papers and all. So even before, see, from my master's thesis, I got a publication in IEEE transactions, right?
Okay.
So that actually gave me a lot of interest and passion, right? So I enjoyed it, right? So then I thought I'll just do it, but I was not quite sure.
Right.
But just like me, so there's a visiting professor who was visiting here that particular semester, right? And he came from US, who became my advisor eventually. So he gave a seminar talk, and he talked about some open problems, right? And it's a graph theory problem. So that I got interested in that, so I basically solved that open problem in a few weeks. And I showed it to him. So yeah, so then he invited me, why don't you come and join, do PhD under me? So that's why I ended up in the US immediately. So 84 December I finished, and January 85 I was there. So what I'm saying, so that way it is very interesting, right? So what I'm saying, so but anyway, so I think that coming back, I think getting students engaged in research is extremely motivating that way, because courses of course you can learn. Now of course you can learn in a much better way because so many things are there at the fingertip on the online and web and Google and everything. But in our time it was more on the books. But so that basically interests me after that I can enjoy research and all that. It was 3-4 weeks at a stretch I was working on that problem. But it was very satisfying. And I ended up doing PhD after PhD. I joined the faculty and all sorts of stuff.
Nice. So
Long answer.
you were
for
not
you.
working in graph theory in your masters, or?
No, but masters actually I worked on the distributed systems, right?
Okay.
But I use graphs wherever I can.
Okay.
Yeah. My PhD was parallel graph algorithms.
Okay.
But in masters actually I was using something called Petri nets. If you know.
I know.
But Petri nets also is a direct graph,
Right.
right? And Professor Naravi's PhD thesis was on Petri nets.
Oh.
Actually, Petri net application in some flexible manufacturing system. So yeah. So in that sense, of course, I see. And coming from Calcutta to here was also an eye-opening experience.
Okay.
Right?
The culture and
One is culture, but what I'm saying that, so you're there, right, most of the students will be Bengali students, most of the students, right? And some, of course, other people who lived in Calcutta. Right? But here you come and you meet a lot of, I had fantastic friends. In our time, we had only 20 seats for the masters.
Oh, okay.
20 students, right? So we made good friends, right? We used to play intramural, and hostels were different. I stayed in the G block behind the library. Now it is multi-story, right? It used to be only 2 floors.
G block. Okay.
It used to be called G block just behind the library.
Okay.
So you probably have not seen it. So you used to have 3 messes, A, B, and C.
Yeah.
Those things probably don't exist anymore.
All the A, B, C, D are there. I think they're mapped differently.
Differently, yeah. Where A was, that's the restaurant, the restaurant.
Yeah, that's somewhere.
It used to be. But it used to be 2-storied only. The first floor and the second floor, G block. I was in G13, and
C was pure veg, I heard. C was pure veg and
C was a kind of mixture. A was pure veg, and B had veg, non-veg both, and C was, mostly C was more like married couples separate. So there's a married couple apartment was there behind. There's a ladies hostel, right? That's right.
That used to be.
Yeah, that's right. So, yeah.
okay.
So C was more flexible time, maybe timing, and so.
Right.
So it was different. But the experience I had over here is good. Campus is very nice, and so it was 1.5 years, but very memorable.
Right.
Very memorable. A very short time, but very memorable time.
So the thing is now, like, so you started off with distributed systems
Yes.
and then into graph theory, and now you're like all over. Like, so like, how do you? My question, like, how do you like? What's the question? Is that how do you select when to enter into a new area, or and would you advise a student to do that, for example?
So the thing is that, like, what happens sometimes.
Were any of you there in the talk that I did?
I was actually not in. One of the thing actually was that so because you have worked on so many things.
That's right.
Right. So it's sometimes what happens is that, say I am a PhD student and my guide works on one particular topic only, but the guide, they feel like, of course you can see if you can find a problem, but my expertise is here. Then how would you advise such students to that? Okay, how do you get started? And similarly, even entrepreneurs, when they want to solve societal problems, they have a lot of passion, they have a lot of motivation. So then how do they pick out which problems they can solve?
Yeah. So he was answering your question. I think his question, like, if I understand correctly what you said, the transitioning from this distributed system to graph theory, blah blah blah, wireless mobile computing, sensor networks, cyber physical systems, right? So I think, first of all, I'm in academics for more than 30 years.
Yeah.
So it's a long span. From let's say 84, then PhD, and faculty for 31 years. So I think the goal should be for any researcher, including PhD student, to focus on fundamental things. Whatever is your domain. Is it game theory? Is it program verification? Is it crypto? Whatever. Just go to the very basics and fundamental concepts.
Right.
Even the definition, because sometimes all the questions are hidden in the definition itself. I understand the definition, I understand the boundary condition, the models and assumptions, I know the solution methodology, right? So we cannot actually ignore those and just see the results of the theorem, right? So once you have the fundamental concepts, so at the outset it may look all different topics, but you have some fundamental basics, right? So that could be either algorithms or graph theory or optimization techniques or game theory, whatever, right? So you are basically hinging on that. Now different application areas emerge, whether it's a crypto or the security or cyber physical system, sensors, smart environment, doesn't really matter. You have to just see the connection, right? So that's why transitioning from, say it's a problem solving is the key. So if you know how to solve a problem, means I give you a very simple application that comes from industry, or you have an idea, right? A simple problem, but I know how to formulate the abstraction of the problem.
Right.
And the abstraction may be an algorithm, maybe a graph theory, maybe something else, right? Or model, probabilistic analysis, right? Then you're basically solving the same. So if I give a very vivid description. Let's say I give you a problem. Application, some simple application. Let's say something is happening on the street, right? But if you think that I have a black box where I abstract the problem, and this black box actually I know all the tools and techniques. Because all the tool boxes are there in my bag of tricks that I know, right? If then I solve it,
Right.
that's not enough yet. Then what do I need to do? I have a problem that I map to a problem that I have a good handle on that abstraction, right? I have solved it. Now I do the reverse mapping. How does it apply to the problem that I started with? If I do that, then basically I have in between a black box.
Right.
You give me a problem, I convert that to a problem that I can formulate it and I can solve it, and I tell you, okay, solution of this means solution of the original problem, right? So if you keep that in mind, so that should be basically, in my opinion, a very powerful, simple paradigm. Right? That means you give me a problem, I know how to abstract it and formulate a computational problem or computer science problem. Solve it. Then I say, okay, my solution means this, right? That's your question. So your question is that your interest may not match and resonate with your advisor's interest.
So,
Yes,
that how do you go about finding
Advisor.
not just advisor but
Problem.
yes,
Right.
more than that, because
So if you, let's say, make a scale of the, let's say, you have an idea, you have a problem, you have an idea, you have a solution, and you have a finished paper, right? Let's say you scale that in a 0 to 100. Effort. Yes. So defining a problem is, in my opinion, 30-35% of your effort.
Yes.
Right? What is the problem that I'm solving?
Yes.
What is the objective? What is the significance? What is the goal? And that takes 30, and you should not bypass it. If your professor gives you the problem, that means you bypassed it and you started over here, and you miss the most important and fun part of it. That's very challenging. But once you have, because if the professor has thought through the problem and gave you a problem which is ready made, right? Once the problem is well defined, solution may be hard but is easy to find. Let me give you a simple analogy. I'm flying out tomorrow morning. 7 o'clock is my flight. What is my objective? It is the airport. What time? That's 7 o'clock is my flight, international flight. If I want to reach by 4 o'clock, that means let's say I start here at 3:30 from CBH or whatever, right? Very well defined objective. That means I have to get up, get a taxi, go to the airport. Now, once I have that objective, and I give it the driver, even if the main road is busy or congested or a bridge is broken, he knows another alternate route. You can go to the airport because you know clearly the objective. But if I do not have any objective, even if I get up at 6 o'clock in the morning, I do not know where to go. Very simple analogy, but here's the same thing. That means I know this is the problem, this is the objective I want to solve. Then I can see, okay, what are the solution methods, techniques, tools, mathematical know-hows that I need to know to solve it. So what you asked is a very fundamental question. So most often, beginning researchers, PhD students, they try to bypass it or they don't spend enough time to define the problem. Right? So the problem definition is the crux of it. Once you have that, just like the objective, I can find multiple ways to approach. Some of them will work, some of them will not work. But I have a clear-cut goal. In that scale of 0 to 100, I would say 30-35% effort actually goes in there.
Okay, so I have a question.
Sure.
I mean, I am thinking about PhD.
Right.
But
You are doing MTech or MS research?
MTech.
MTech, okay. Why are you thinking?
Huh?
Why are you thinking?
No, I mean,
Thinking how to phrase the problem.
No. I say, why are you thinking to go for PhD?
Oh, okay.
well, you
No.
want my motivation?
No, he's like.
Why am I just
why not
sitting?
sure?
Why am I
Wondering.
Okay, fine. So, but the main question that I have is like Europe versus US.
Right.
So US has 5-year PhDs, which gives you some time to probably
But
come up with your questions.
US never puts a timeline. It could be 4 years, 5 years, 6 years.
Yes.
We don't want to be somebody to be for 10 years, but they don't put any stipulation that it has to be by 5 years.
Yes. So my question, my hesitation
Right.
is that whether I should go for Europe again. Europe PhDs are 3 years, and then they ask you to submit your thesis.
Right.
So the thing is that in masters I'm already working on some set of problems in some areas which I do like, and the groups that I'm considering for PhD in Europe do work on sort of those areas. So I'm pretty sure that I might have a problem even before going. Since I've been working for a year, on my own I might be able to find a problem and then go join as a PhD, which is fine because again, like you say, right, the important part is
problem formulation.
Is formulation. So if I do find that, then I feel like going to Europe would be fine. But I want your thoughts on this. Like, how should I?
I know what you're asking, but go ahead.
Because that is why I'm on the fence about what to do.
So I can tell you, because I got my education in US for my PhD, right? And being there, and I also go to Europe quite often. I have my collaborators in Europe. Now, how much time does it take to get PhD here?
Depends.
On the average.
4 or 5 years.
Average, I think 5
4
to 6.
okay, I don't know. ML, most people 4.5.
Yeah, right.
In the AI pool. So our lab, 4 to 5 years.
Yeah, 4 to 5.
So what I'm saying, so I'm asking that question because, so IIC also, or in India they don't say 3 years, right? So there's nothing wrong. You know this definition of the problem. You just work on that, right? So, but in the US system, I can tell maybe that US system actually teaches a PhD students to be independent and having good breadth and depth.
Yes.
See, in Europe, mostly the coursework is either not there or 1 or 2 courses or 2 or 3 courses, that's all. But in US system, what happens? They expect you to have a breadth. And that comes back to the question, how do you switch from problem to problem? And the breadth actually helps there. And then your thesis becomes a depth, right? So US system actually is a combination of breadth and depth. Because things will never stay static. What you're working now, just like me, 5 years down the road, 10 years down, you'll work on different problem. But your fundamental still, foundation is there, but something else, because new technology evolves, new problem emerges. And you want to explore that because that's what is your inquisitive mind, right? And the breadth actually gives you that independent confidence on that. Right? You may not be working with machine learning, but you already have a breadth of certain set of courses. You know the basics and the fundamentals. You are not afraid of changing the topic because you have the basics covered. So that's the main difference between the US and the Europe, in my opinion. You are just from day one, you're going to the depth, but so what you think is the depth now may not be depth 5 years down the road. So, but a breadth and depth combination, just a graph traversal, you do breadth first search versus depth first search. You can also do a combination, breadth, depth first. You do breadth and then depth, breadth, depth together. So it's one of those. That is one part. Secondly, if you're worried about 3 years versus 5 years, you are young.
No, I'm worried about the timeline. I'm just worried about, so my problem is that those 3 years will not allow me to
mature into
a proper researcher.
Yeah, but no, you do proper research, nobody will give you so that's not the point. Point taken is that taking the challenge. See, here you are putting in a comfort zone. I know this problem that I defined over here, I'm continuing on that. You are in your comfort zone. Where were you challenged? You never got the challenge, right?
Yes.
But you go to a new environment where you may work on those problems that you have been thinking or something different. That means coming back, that means you already learned the skill how to define a problem. I'm fearless. I like the challenge. I go somewhere else, why should I care? You give me a problem, I know how to define it. So I think that fear, that's why the confidence and independence that you build, that you'll be fearless, right? It doesn't matter. You give me a problem to do on machine learning, I can do it. Something on network economics, game theory, I can do it. Tell me something on optimization, I can do it. Because I know the basic skill of defining a problem from an application or from scratch. And once that is there, then of course I have all the tool sets in my box. Right? So, once you develop that skill, that's very powerful, that's a lifelong learning. Right? Then you are not, so basically, you are not looking this way, you are looking that and then that, both. So that's the main difference, I would say.
So related to this question, so we'd asked the CSA students whether they wanted to ask you a question, and one that came up was that how do you choose, how do you take a call whether or not you should be going for a PhD?
But even before that, I have a question. It's related to the previous question that you mentioned. The thing is this, so you mentioned that everyone should work on the fundamentals, and then so that you can always reduce an existing problem to a,
that should be the goal, the eventual
right?
goal, and that doesn't happen overnight.
Yeah, right.
You have to work hard towards it.
And I saw this analogy last week as well, when there was a talk by Google's vice president, I forgot his name.
That's
So
it,
he was talking about the AI, history of AI. Yes, right. So, and Harisha sir mentioned this claim that this is because he's been working on fundamental problems in IIC which helped him to, reach a level quickly. And now my question is this. So, as an analogy to the 35% of the time goes into the problem solving.
That percentage may vary, that's my opinion.
I mean, my point is, if someone misses out on that aspect, you miss out on a lot of things.
That's right.
So, similarly, if a person does not experience fundamental research and is more into empirical, I'm assuming that it's not fundamental firstly, so an empirical research where you have some results and you try to implement and get some improvement or incremental approach over and what are your views on those research?
So I say fundamental concepts.
Okay.
There's a difference, right? So every research has a fundamental concept.
Okay.
You think about, I designed this, let's say Spark architecture, Apache.
Right.
A very system that I developed, but there's a fundamental concept that helped me develop that system, which is super. Think about a wireless network, a cellular concept, right? A smartphone, right? So, what is fundamental research or applied research? That's a different question, but there's a fundamental concept that went into the whole process that gave this innovation. Your question was the innovation, right?
Right.
Now, some research will be fundamental research, some research will be applied research, but the concepts are very profound. It's not an ad hoc design. This system which is very efficient, this system which sells the battery as best as possible, all sorts of different things. Right? So the fundamental concepts comes from the understanding of the problem. And I say, I understood the problem, I know what it means, I know how to apply it. That means any course that I take, if you understand the basics and the fundamentals, that's the key. Even the book may have 10 chapters, the teacher taught less than 5 chapters, but you understood each and everything, you can read the rest of the chapters. But if I don't understand the fundamental concepts, then everything is incomprehensible to me.
So understanding of fundamental concepts come from the course, right, and not the problem, right? So I don't understand that.
Both.
Right.
So because you build the foundation, it's like a stepping stone. Let's say I'm building a 3-storied home, I have a foundation which is under the ground with concrete, metal and everything, right? So the courses give you that fundamental concepts. You may not realize why it will be useful, right, at that time. So, I want to be a software engineer and why discrete math and algorithms do I have to learn, right? But this still gives you the very fundamental, am I writing the best possible code? Then I need to analyze the time complexity, space complexity, memory. If it is a wireless network, the bandwidth. If it is a small IoT device, smartphone, then energy is another resource, right? So courses actually, either you learn it yourself, PhD, of course, you learn many things yourself because you don't take course for everything, right? You learn yourself, but your basis was the foundation that you have built over the years. So the courses actually help you that aspect of it. Then when you go research, you're going beyond the books, beyond the known knowledge. So research is beyond the known knowledge. It is not there, and you are creating that knowledge. The same way you learn these things from the book and other papers, your paper will be read by others.
So what you're saying is that any sort of technical student, whether or not they're deciding to go into research, should really focus
on fundamental
what is the
understanding.
core of the problem they're solving, and maybe teach themselves the very basics of...
Absolutely. The fundamental concepts.
Yeah.
Right? So if I understand that, then I have confidence that I can learn the rest. Right? And your question was how to decide whether somebody should go PhD for PhD or not. So it's a litmus. So for example, if I have not done research in my life any time, either undergraduate students or master students or life, the research has no meaning to me.
Yes.
That means somewhere, for example, you are doing your master's research and you got interested or motivated to go for PhD. But if you did not do that, that motivation, very few people may have it because those are very rare, self-motivated, right? But sometimes by doing it, you see whether you are enjoying it or not. Research is not for everybody. If everybody gets a PhD, the society will be polarized, right? You don't need that, right? But you still need a good number so that higher education can sustain, as new students can learn a lot of things from them. So as I said, like when I was undergraduate, I had no idea I would be going for even masters. But the BTech project actually gave me, and then I saw it. Sometimes things happen. If you think from your childhood, things happen that you cannot explain even why it happens, how it happens. And then when I was doing my PhD master's, it's 1.5 years, courses plus research and all, but I enjoyed it immensely. And then I thought, okay, let me just go. And as I said, like, this opportunity also was like, before I was even thinking, so I just solved some problems, and I thought that's fun because I got interested in that. And then, but so if somebody does it and then they feel that no, I don't enjoy it, that's perfectly fine. Let them do something else. But if they enjoy it, then, but most often actually what happens that I could be wrong. I'm here for a couple of months, but I'm actually exploring, talking to faculty. So many master students over here at Tech, they do not do serious research. Right? If they don't do serious research, they have no idea what going for PhD, what could offer them in terms of opportunity, problem solving skills, in terms of better career, right? Or higher pursuit of knowledge, or reaching their ambitions and career goals. Since they don't do it, they have no clue.
So that's what the reason this is a IISc student question is that lot of people, because I've seen 2-3 batches of MTech coursework students who will do some small amount of research. They'll maybe
it's more of a project and maybe
it's more
exercise
project
and
work. So then they start thinking, but they'll see like I'm doing PhD or some Stanley is doing PhD, and they're like, oh, these people are doing, I can also do it. So then they get conflicted because, like you said before, being exposed to research, no one thinks about doing it. So then they have this conflict. Oh, I don't know what research is like, but these people are doing it. They seem to be fine, but I never.
But there's there's no one strategy that fits all.
Exactly.
There's no one size fits all solution. Some people may have an opportunity they did it, some people they did not. But in this case, if by let's say talking to Stanley, somebody gets inspired, that means he did a very good job conveying what he does and how he enjoys. Somebody he exhibited his passion, and that passion got transmitted to him. He said, if he enjoys it, if he can do it, maybe I can think about it. Although they have not done it. So that means it's not. So that means all of you have the responsibility, because as you are the peer mentors. No matter how young the assistant professor is, students will still think that he's a professor. But when you talk to the students of the same age, so if you want to create a difference in the culture, as a PhD students, do you meet with the master students? Is there any avenue and opportunity to intermix? Except just the friends or roommates that you have in the hostels. So you can actually ask the department, or you all take a responsibility to create that avenue. Just have a graduate students or the research students research club, CSC students research club, right? Then you get like-minded students to come. So let's say you have it every month or every 2 weeks. You can ask the department, give us tea, coffee, some snacks, right? Spend 2-3 hours and build a culture among the students. So then junior students, MTech students, MSc students, they'll be inspired by the PhD student, because they can talk and say, why are you doing PhD? They can ask the same question to you. What motivated you to do this, right? And If you can inspire, let's say every year, collectively, all the PhD students, 5 students who are here. See, you can always get PhD students from outside, and you should do that. But the uncertainty is huge. They may come here, they may not come here. They may be selected, may not. But those who are here, it's easy to mold them, right? And faculty, of course, should take responsibility to motivate and counsel. But even as a student, you are the peer mentors, right? And have a club like that. So when I was department chair for 4 years, not too long ago, I created 2 different, like computer science organization, undergraduate student organization, graduate student. So basically undergraduate student forum, graduate students forum. And I used to encourage them to meet at least once a month. And some faculty will be there, and I said, okay, we'll provide pizza, drinks, and all sorts of stuff. And you guys meet and talk, discuss. This junior student may have a lot of academic challenges and obstacles that they can get help from the seniors. Students who are interested in research, senior. See, doing research is not an easy path, but it is not impossible path. Otherwise, nobody would do it, right? So it is not easy, but at the same time, you need that dedication, motivation, perseverance, commitment of your time, right? But it is doable. Otherwise, all the students who are getting PhD, they will not be in this business, right? It is doable, but somehow that barrier has to be crossed. So, is there any forum for the students to have meetings and open discussions and?
The theory group has this theory lunch thing, which is sort of aimed at introducing different theory labs also to each other. But other than systems have one.
But as a student group, I'm just saying the department, CSS students, let's say, CSS student forum.
The closest thing I guess is DCC, where
what does DCC mean?
This is department curriculum something.
Committee. But that is maybe some students are representative there, right? It's not for the whole students, right?
So that is more for what are your coursework challenges that you're facing or something.
But everybody is not participating. You are representative. That's different, right? So think about if you can create that as soon as possible, as early as let's say early next year, right? You come up with an idea, and I'm sure the faculty will be very receptive. So basically, you become part of this whole process to mentor master students. It's not for everybody. Some students will be encouraged like you, and some other students may be interested. Let's see what is going on there, and you can have very informal discussion, more like roundtable discussion, open dialogues, right? But you can have things that why should one consider for a PhD? Something very general theme which people will not feel threatened, right? Or challenges and opportunities for doing PhD, something like that. You talk about from your experience. You can bring some faculty members, some recent graduates who finish PhD and join someone. That's a very powerful technique, because no matter how young the assistant professor is, students always think that's a generational gap. Because you're a professor, that's what you're saying. Not from the student's point of view, but students talking to students. Even if you're senior, junior, but still, right? You may be graduating next year and you'll be faculty afterward, but still they think you are a student. The psychology, right? And that's different. So those kinds of, in fact, my only regret before leaving is that I asked the department, including, and I told Professor Narore last night to Professor Narore and Professor Bhatnagar that please create an opportunity for me to meet with the students as a whole. Not for any technical discussion, just I wanted to get a good feel what they think about what they are doing, why are they doing this, what is their passion, why are not they doing something else. But it did not happen. I'm here for more than 2 months, and that's a pity.
Yeah, this time is really bad because everyone's exams are there.
But this is now, I'm here from end of August. Just in between I was gone for a few weeks, right? I'm just talking about, since I was here end of August until first week of October, then 18 November until now. So what I'm saying, the reason I wanted to talk is exactly the kind of things that you are discussing now. We could have even more detail, and also let everybody participate in the discussion.
Right.
Because all four of us have limited ideas, but other students have other ideas, right? Right? So I wish that happened, because my only objective was, because I'm an alum of this department and I've been in academics, just to, even when I was a student versus students now, like all of you, it's a completely different situation in terms of the access to the information, in terms of the technology, in terms of career opportunities. All things are different. When you graduated, Infosys was just 1 year old. Nobody knew. The campus interview, nobody cared. They said, oh, nobody knows who Infosys is. Why should we go for even an interview, right? I'm just thinking. So you see that how the boundary conditions have changed, right? So, but anyway, nevertheless, so when I said, let's say 35%, then of course, where does the other 65% go, in your opinion? Is it in a scale of 0? Let's say 35%. For some people, it could be 25%, and normalize it, right? Because it depends on how you define the problem. Where does the other time go?
I actually, in my master's, I was interning at IBM and they wanted to do some blockchain game theory thing. I spent 50% of the effort actually just coming up with the exact problem.
Yeah, because at the beginning it could be.
Because
I'm talking about
very early.
Right. And that could change, right? Because the more you do, more papers you write, more problem formula that could shrink. Right?
But now, so with
then what does the rest of the time go? Or effort?
So with this, so I actually just submitted one paper on incentive compatibility and stable fractional matchings and all. So their problem definition was sort of simple from prior work. Like it wasn't, oh, this is just really clear because matching.
Because you see the connection very quickly now.
Because matchings are anyways very old, so you already have good models and everything. But I feel.
And also you have more experience. See, you have to count that, right? The experience that you gathered, that minimized your.
But I felt 30% of my effort went in just writing it up.
Very good. That's what I wanted to hear. So because it takes about 30% or even more. And right, so it's not like another 65 or 70% I'm spending solving doing the math. Nobody would care unless you really express your ideas in the rest. So exactly. So you can just see that if 30% here, 30% there, your actual problem solving is not much effort.
But
it all varies. Depending on the different. If it's a very challenging problem, maybe a little bit more, a little bit less. But yes, about 30%. I'm talking about average, right? Somebody may take less, somebody more. Extremely important because you are conveying your ideas, concepts, and the science through writing, and most often conferences is blind reviews, anonymous reviews, of course, and journals the same way. They are not talking to you, so they have to understand exactly what you wanted to convey, and it is science, not a fiction. It's not like, okay, you just believe me. It has to be, everything should be logical, you prove by theory or experiment or whatever, right? And so writing is a very powerful skill. And I'm glad to hear that because I have had students who solve the problems and say, I'm done. I said, well, what do you mean by done? The writing. It's not a good. Also, nobody would care to read unless, because they have to understand how you logically develop the solutions and what are the deeper insights.
That's I feel like.
And it's a very good skill.
It initially is very challenging because you know what you are talking about, but you don't know how to explain. Yeah, that's obvious. Yeah, of course. But and this actually I feel happens with students also in like just writing answers.
Answers
After being a TA.
Exactly, because you don't give the derivations, you just it's almost like an objective question that you guessed it. How did you come up with that? That is one, and also it's a fundamental concepts and the insights, deeper insights should be beautiful. And so you read it, wow. Shivani, right? Shivika. Sorry. So how did Shivika think about it? As a reader, as a reviewer, if I had that feeling, wow, beautiful. Let's say you walk across the campus, you see a beautiful rose flower. What is your impression? beautiful, right? What? So your research should be just that factor. Wow, how did you do it? See, wow and does not mean it has to be very complex and incomprehensible. Very simple concept, but very powerful concept. Good implication, good significance, right? Because simplicity is the beauty, simplicity is the elegance, right? So if I read your paper and I get that feeling, most of the time that you buy the reviewer's heart. Even if you have some mistakes and flaws, they say, they know what they're talking about, they can fix it. So they'll point that out, but they'll never be negative in the outcome. Because they already got impressed that yes, the way you develop, most often in the papers, people read 2 to 3 pages, at the most 4 pages, they make a decision. You know that, right? And that part is not the technical yet. It's the introduction, motivation, the background, that means how you position yourself. You setting the stage, right? By reading 3-4 pages, they make a decision whether it will be accepted or not. If they feel accepted, they'll read the rest. Is rejected, they have this much of negative points already. Objective is not clear. I have no idea what they're working on, what they're doing. You can see all very generic comments, and I'm sure that you have seen those reviews, right? Objective is not clear, and if they find typos and grammatical mistakes, there is no excuse, right? Because you can always find this half a page writing, this sentence is ill-constructed, right? There's no technical thing, but fundamental thing is, see this. These reviewers, they are unpaid. They are volunteers. Why do they do it? Because they love science, just like you. They want to promote good science. And if they do not feel excited with the science that you create, they have no reason to accept it. That is one, and also fundamentally what they assume that once they read the abstract, they read the introduction, they find grammatical errors, typos, immediate impression is you never cared as an author. Fundamental hypothesis, if you did not care as an author, why should I care as a reader? Why should I care to read? Because you never cared to pay the meticulous attention in writing. So you can just see that the front end is the problem definition and the back, the last end is the writing, and in between all the nitty-gritty details that you solve. And you understand that very well. But the whole thing makes it very innovative. What else?
So actually,
have some more questions?
Yeah, we didn't even get to your work.
No, that's okay. I'm very passionate about these things.
So maybe we can, before coming back to research again, we go to a kind of tangential and then
whatever you feel.
So this is specific. So one person specifically asked this from your talk actually.
Right.
So he was like, this is specific to to you, and he asked that.
That person was there in the talk?
Yeah, that person in the talk. So he asked.
There's actually more people on our team, but all of them have gone home after exams.
Right.
Yeah.
So it became.
So what you're asking us to, you actually asked everyone to identify a quote of Rabindranath Tagore, and his question to him is how Rabindranath Tagore or any other Bengali eminent figure influenced him in his research. And
Me?
Yeah, influence you, yeah. And I think this question is more like...
It's a very good question. Yeah. You grow up with something, right?
Right.
So, where are you from?
So I'm from
Kerala?
Technically I'm born and brought up in Mumbai, but technically from Kerala.
Yeah. What about you?
Thane, which is
Mumbai.
just outside.
Thane? Okay, Thane.
Delhi.
Right. So, whatever you see, your childhood, school life is your formative stage, right? Wherever you are, you grow with that culture and tradition, right? Now, even in that culture and tradition, you always find, as in Maharashtra, maybe, I don't know, Lata Mangeshkar or whoever, if your music is your passion, you'll have some, right? Or Asha Bhosle, right? So similarly, what I'm saying that wherever you grow up, it's not just the science which is important, right? You need to appreciate and understand, if possible, art, culture, music, sports, whatever. There's some hobby, some passion, right? And you grow with that, right? Now, when you get good personalities or great people like Rabindranath Tagore, Swami, I can give tons of quotes of Swami Vivekananda. So, and they were from that region, right? So you read their literature, you read their writings and the deep philosophy. So because somebody will not get a Nobel Prize unless they have that depth, right? Or somebody like Swami Vivekananda create a lot of contribution. So basically, you learn those things, right? But point here again is, no matter what field people are in, they can excel in that field again when they make a deeper contribution in that field. The literature, music, whatever, right? Writing and all. So, and many times deep philosophy is embedded in those. Right? So I do not know how much you have read Rabindranath Tagore, for example. His writings are very deep in terms of the philosophy. And there are some poetries and songs are there where you would think that he is a scientist. But again, the science is writing through his poetry. Right? He's talking about the universe, he's talking about many different things. Even the notion of finite and infinite, limitless and limited. So he has songs and poetries where he talks about those concepts. But again, like expressing himself in those, right? So that's one part. So I think each of us, no matter what our discipline is, should read biographies of lots of scientists, poets, and all, because that's how you get the inspiration. If you read Einstein's biography, Newton's biography, that's inspiration by itself. How did they do it? They are also human beings. Similarly, you talk about Mahatma Gandhi, Swami Vivekananda, Rabindranath Tagore, or whoever, Radhakrishnan. So, reading those actually is inspiring. Many times they say things because, and Rabindranath Tagore was a very good teacher, because you know Vishwabharati, that's in Shantiniketan, right? So, he developed that, and his method of teaching was very unorthodox. Right? And my hometown is not too far from there. Very unorthodox means he'll say, okay, now it's raining, so let's go outside, sit under the mango tree and study. Be close to nature and enjoy nature and study. And his philosophy was that thinking, creative thinking and innovation cannot happen within four walls of the room. Right? Because we use the word out-of-box thinking, right? So if we say the out-of-box thinking and we are sitting inside the box, how can that happen? Right? So if that particular quotation, I connect, it's in my heart. So I'm not sure whether I've seen it. I'm not saying, since you're not in the lecture, I'll tell you. So what his definition of teacher? He's saying, who is the master teacher? Because he said, a teacher can never truly teach unless he is still learning himself. That's his first line. And a teacher can never truly teach unless he is still learning himself. The second sentence is, a lamp cannot light another lamp until it continues to burn its own flame. Let's use a candle, you burn that candle to light another one, right? Then he says, a teacher who has come to the end of his subject has no living traffic with him, but merely repeats the lessons to the students. He can load their minds, but he cannot quicken them. He cannot quicken them. I mean, a teacher who has come to the end of his subject has no living traffic with him, but merely repeats lessons to the students. Can load their minds with information, but cannot quicken them. Right? And this is a very deep philosophical thing, right? But later, actually, when I was talking to Professor Narahari and other were there, what they pointed out, actually in Upanishads also, this same philosophy is there. He just probably wrote in his own way, right? So, that means in our Vedas and Upanishads, these are the deep concepts, philosophy, right? That means a classroom is a platform for learning, but this learning is bidirectional. Just like the communication, when you talk to the phone, if one person can listen, other person cannot listen, that's a unidirectional communication. That's not good. So that means a teacher, students, the learning should be mutual. You learn from the students learn from the teacher. Right? And it should be dynamic. Learning environment should be very dynamic. It's never static. Right? And it is not the loading of the information. As I said, like you have 10 chapters in the syllabus of the book. Even if you learn 5 chapters very well, the rest you can learn yourself. So that influence has been there. It's a long answer to your short question, but I think reading biographies of scientists, no matter who they are, reading biographies of poets or great people is an inspiration by itself. And you can always translate that in the research parlor, in writing, whatever going on. What else?
So how much time do you have accordingly? I can continue.
I can spend some more time. I know I have to go, but
okay.
But let's just do it quickly.
Okay. So then
I'm too passionate about when it comes to students, right?
Okay. So
That's
I think
wonderful.
there's just one question left.
Right.
Yeah. So I just.
And you can take the rest of the questions if you don't have any constants. You can walk. And you cannot stop. But ask the questions that you have in mind.
So
then
one is just one question is related to your talk,
right.
and the other question is like a general.
Sure. That you can take on the walk.
Yeah,
right?
sure.
The
recording.
okay.
Yeah.
Sure. So okay, so one is this the smart living and cities are buzzwords, right, these days, and how do you explain like smart living cities to a general audience, and like what are the major issues which are like unaddressed in smart living and IoT in general, and I think that's it. Yeah.
I mentioned about there also. See,
Okay.
one is buzzword and another thing is just like anything. So I can always instrument this environment, the city, let's say this home, this building, right?
Right.
With communication, computing, technology, sensors, IoTs, to collect some information.
Right.
You're putting these devices or technology to gather information, right? I can always instrument it to make it. For example, I buy lots of gadgets and put it there, right?
Right.
But as a researcher, our objective is to find the fundamental research questions. There are tons of research questions.
Right.
And these such questions were not there before this technology was there. I will give you a simple example. The smartphone, how old is it? In general, the concept of iPhone, smartphone, Steve Jobs, when he conceptualized.
This was 2005, right? The iPhone, but I mean before that it was I think
So
1990.
we
But
had-
those are the cellular phones.
So
mobile
there were
phones.
those PDAs,
Oh,
right?
Yeah,
PDAs.
PDAs.
89.
Yeah, but I'm saying the smartphone concept.
1989.
No, but that
No,
was
no,
those
just
are
like-
cellular phones.
Cell
Like
Yeah,
the
smartphones.
start of this decade around.
2007, 8.
Oh right.
Right.
Yeah. Okay.
Yeah, the mobile phones were there, but they are smartphone, right? But
Right.
before this one, see, when Steve Jobs from let's say Apple, right? Initially, then of course everybody else picked up. He had certain things in mind, how to integrate let's say music with this thing, that thing, iTunes together, right? But once the technology got little maturity and it evolved, now you can see how much utility it has. It has made camera obsolete mostly. Unless professional photographers, right? Most often you have this thing and take pictures. You're recording it. You don't use the boombox anymore for recording, right? Right? You just see that this is a multimedia device, so powerful. Right? It has memory of this. What I'm saying that's one part of it. But there are tons of other use of this. So for example, I can have a simple app. And the app could basically could be even for health and well-beingness. Right? Oh, I'm not doing enough exercise, I'm eating lots of calories and all sorts of different things. I can have an app which can monitor my eating habits, and I can get a prompt every day. Oh, you need to do more exercise, you need to cut down your carb, whatever, right? You can just see the simple things, right? But nobody thought about this type of applications when the technology was created. But once it is there, then our imagination, how do I take it to the next level, right? But that's the technology piece, right? But as a researcher, we always think that what are the fundamental research questions that you can ask? Right? So in the smart living space, I alluded to some, but not too many, because the audience was kind of heterogeneous. There are lots of fundamental problems that you have not seen before. And that happened because I have the technology and I have an opportunity to collect data. So the question is that what are the things that I can do? So simple question I can ask, let's say you are in this building, and let's say this building is smart, right? If that is the case, then I have an algorithm, for example, I can tell you in the next half an hour why you will be in this building. And I have a way to learn it because our lifestyle is very repetitive. Right? So this is one example, but very fundamental question. So what we have developed a solution, an algorithm, that is based on online algorithms, information theory, dictionary compression, right? All these things. But these are very fundamental techniques, right? But the problem originated because I have a smart environment and I want to predict the location of the users in that environment. So how do I learn their activities? How do I learn their mobility, right? But some of these questions will not come unless I have a technology which gives me that opportunity to collect information, right? So this is a simple example. So similarly, let's say, so smart living, the concept is the application of technology, communication, computing, sensing, IoT, which improves our quality of life, which makes us more productive and efficient, which makes our society very safe and secure, right? Now, that's a very high level objective, but underneath, for example, if I say it's very safe and secure, that means many questions that we ask in security, it's not just crypto, not just encryption, but security of people, assets, information, networks, systems, all sorts of infrastructures. Right? So security safety means all of these. And crypto and encryption is just a very minuscule part of it. How do you make this building very safe and secure? So there is no accident, right? Or there is no terrorist attack, there is no bombing, right? So you have surveillance camera, this thing, that thing, but still, you see today's world, it's a simple example, still things happen. That means all the solutions that we have are not enough. That is, there are still more problems to solve, right? Similarly, you talk about smart healthcare. How do I keep somebody healthy? So smart healthcare is not only for people who are about to die. For all of us, how do we, simple example, right? Doing regular exercise, eating healthy diets, all these things, right? That means I'm keeping somebody in a shape that they don't have to visit the doctors unnecessarily. They don't have to fall sick, right? So all sorts of things. And then of course for the elderly people, how do I detect their fall? How do I prevent something happening? Another example I mentioned over there as well. Could I use this smart technology to prevent a suicide attempt? You see how impactful it is. If you can save one life, right? And I have the opportunity now with technology, because you are monitoring their behavior. See, their behavior, that could be their depression, their activity, what they do. So think about any research that you do. You just think of what is the impact of that. Impact may not be just the new startup company or one more paper, exactly. Right. So does my research have a societal impact? Right? Yeah, of course you'll be writing paper, but go beyond that. If you ask this simple question, when you do research or write paper, who cares? You ask this question, who cares? I have a sophisticated crypto method, let's say secure multi-party communication, but who cares? If you answer that question, you'll always be thinking, what could be a good application when my research will be very useful? Or can it save somebody's life? Can it save a terrorist attack? Can it save a bombing at some place? Can it save improve a child's education? There are many different ways to connect the dots. It takes a lot of time to think and go beyond. So basically, I should go think beyond what you're, connect the dots, right? So there are many different ways to do that, and it doesn't happen overnight. You have to go through that experience, right? It's a long process, but. Any other questions that you have in mind?
So it's just
So we can.
general advice.
Is it okay that we can walk? If you don't mind.
Yes, sure.
Let's do that. Actually, I have to reach I was supposed to reach CBH by 4, but I can actually reach another half an hour.
Should we call the?
No. I want to work.
Sorry?
You are calling the transfer.
Yeah, we
No,
can.
I want to work.
Okay, sure.
No.
So yeah,
That's okay. So we can, as long as you want, we can work on the talk and then we can,
No, it's just a general advice question.
No.
What to summarize, right? Like what would you
This
like
is not an advice in learning, right? So what I'm saying, I want to meet with the students to learn from, because so everybody has something. There's a famous statement. You can always learn something from somebody. Very simple thing, right? If you keep an open mind, because everybody has something to offer. Doesn't matter whether somebody is junior, somebody is inexperienced, whatever, because people think from their perspective, right? And that perspective is very unique. And only it is our ignorance that we don't encourage. So that's why in the classroom, I try to encourage students that you ask questions, no matter, no need to think that your question is silly, your question is very simple, because, what is that?
I think that's just a piece of paper.
Piece of paper. One thing that I can tell you, that so when you do research, let's say if you talk to all the time your another students in game theory, you learn one thing. Of course you learn, right? But talk to somebody who is somebody else's student. No, I'm just giving an example. No, I'm just saying.
Yeah.
So, because you know each other, right?
Right.
You play together, you eat together, you work together, go to movies together, whatever. So, and when you talk, somebody who is not in your specialized area, if you can explain that they can understand, that means you understood the problem. Because students in your lab will understand what you are working on.
Exactly.
Right? But if they can understand, right, that's one thing. A second thing, they may ask, since they don't understand what you are working, right? Unless you explain well, right? They'll ask very random questions, right?
Yes.
But many times, random questions will be very simple. So one thing that you mentioned, that when you are writing paper, you think that you know everything.
Right.
See you later. Huh? So that means you assume that everybody should know it, but they don't.
Right.
Right? So the thing is, since they don't understand, they ask a very random question.
Right.
But that very random simple question could be clue to the solution that you are looking for months.
Yeah, that's true.
Because you are blindfolded.
Right.
You are very biased because you just think that you are not thinking beyond. Right?
Right.
So what it basically means that simple random question from somebody who is listening for the first time, because he does not understand and he is asking you questions because it's not clear, that could be the solution, a clue to the solution that you are looking for months. Right? And so talking to people across different groups and all, so I need to return the key because I am giving it tomorrow. I give it to you at the government office. Please. Huh? Thank you. Yeah. I remember. So talking to groups is also very important.
Right.
But I'll be back here maybe when this CSA 50th anniversary final event will be here next July.
Okay.
For a few days I'll be here. But I'm saying that I'd like you to form this student organization.
Okay.
The department is not like anything fancy.
Right.
It doesn't matter who is. You don't have to create a structure, president. No. It's just a forum.
Right.
More like open dialogues and forum. That's every Friday, end of the week. Dedicate 1 or 2 hours, late afternoon, 4 to 6, 5 to 7, whatever, right? And then exchange ideas.
Right.
You'll see that so many things will. And even if everybody says in 2 minutes, what is your research area? What are you working on? What is your passion, right?
Right.
And so it is not advice. I would say, in my opinion, it's mentoring which is more important. It's easy to be an advisor. It's very difficult to be a mentor.
Right.
I can always give advice, right? Do this. That's advising, right? But mentoring is letting the student explore.
Right.
But whenever they're stuck, they will face obstacles. you try to remove the obstacle so that they can see the light.
Right.
Right? Which is difficult, but doable.
Right.
So, yeah, I don't use the word this PhD advisor, master's advisor. I use the word more mentor because they really help you succeed.
Right.
The very definition of mentoring is basically sparking your imagination, right? Giving you the inspiration to see the light, right? So it's almost like what you have in Upanishad, Asatoma Sadgamaya. You know that?
Yeah.
Asatoma Sadgamaya.
Okay.
Bring me from the dark to the light.
Right.
But this dark means ignorance, right?
Right.
Light is your knowledge.
Right.
Right? So it's an Upanishad thing, Asatoma Sadgamaya. From untruth to truth, from darkness to knowledge, right? Or ignorance to knowledge.
Right.
So, but I think, Shivani, you had this question. So, this choosing an advisor on a topic is extremely important.
Right.
All right. So now, how would you know it? There's no formula, right?
Right.
But topic you can always choose, and then I do not know how it is done. Is it more like when you join PhD, you are assigned, okay, he's your advisor or she is your advisor, or you have an opportunity to explore?
So in CSA, usually when you apply for PhD, they'll you say that okay, I want to say work on
The
game
topic,
theory or
right?
something.
Broad topic.
So since I had said I want to work on game theory,
Right.
then I was assigned Nalhari sir also.
Right.
But I still have an opportunity to switch to someone
Very
else.
good. That's important, right? Even if
So they'll give about maybe a month and a half, or
Right.
now I guess 3 months. I don't know.
3 months may be too short again. At least a semester should be there, because see, as a master student, you think you'll be doing machine learning, right? No, there's nothing, no punch, right? No punch. But I'm saying, but you may not know what it is. But once you explore, then you find out that's not my passion, right?
Yeah.
So,
Yeah, I
but
mean,
so at least one semester should be there. If not one, you have to explore, and then find what is your passion,
Right.
because if the passion is there, rest is done deal,
Yeah.
right? Do you play any sports or games?
I play table tennis
Table tennis. Why do you play table tennis?
because I enjoy it.
You enjoy it. But nobody forced you to play table tennis, I guess. Maybe at the very childhood, maybe parents say, "Oh, just go to the table tennis class," right?
No, just
But that does not sustain, right?
right.
In the long run, you
Right.
enjoy it.
Right.
Do you play any sports?
no. I mean,
You
She's
watch
an
movies?
avid
I
reader.
enjoy reading.
Reader? Why do you read?
I'm absolutely in love with literature.
Literature. But do you read everything that you get?
Not now. I mean,
But I think she's almost completed everything.
No, I'm just asking the question. Because
no, I
she's a very...
try to read different authors and different genres.
Right. Do you read like every author? Why not?
Because it's, well, literature is very personal. So
No, personal is fine, but let's say you like certain authors, certain you don't like.
Yeah,
So what is the root cause of not liking it?
So I associate the reason with what kind of personal experiences you've had.
Right.
Yeah, and how do you relate to.
You want to relate, right?
Right.
And when you read, what is your feeling?
Sometimes I get chills.
Hmm?
So
No, I'm just, let's say you read a very good book from a good author that you cherish to read, and once you read, what is your feeling?
it's really, well, the physical aspect is I have had shivers reading some of the works,
Right.
like Milan Kundera and Garcia Marquez.
Right.
But more long-lasting effect is that they become a part of you. They become a part
That's
of your
right.
philosophy.
Right? So it becomes part of your life, right? Okay. So, do you watch any movies?
I watch a lot of movies. I read also a lot.
Right. No, of course. I'm not saying it's exclusive, right? You can do all of this, right? You can play games, you can. But
Yeah.
again, coming back to the movies, I don't want you to be grasped by the vehicles. So why do you watch movies?
When I want to.
I'm asking the same question. Why do you play? Why do you read?
Oh, okay.
I'm just
watch
asking
it.
the same question, right? But in different
But
context.
yeah, for me, I watch movies because I want to sort of forget what happened during the day.
Okay.
Usually
So how would you characterize, what attribute would you characterize it to? That means you want to refresh yourself,
yes.
or relaxation,
Yeah, basically
relaxation and
relaxation.
refreshing,
Right.
right? But again, the same question like book. Do you like every movie that you watch?
Definitely.
Not. Who creates that ambience that
Right.
is very attractive for you to watch a movie, and some other forget it? So who does that? Who creates that atmosphere or ambience that you say, okay, this movie
The actors,
The
Direction.
cinematography,
the way they've really
sell
the
it.
tone of the film a lot, right?
Right.
Like,
So it's a combination of many things, right? Direction, story, writing, right?
Yeah.
definitely.
Playwright,
Right.
acting, cinematography. So it creates a long-lasting impression in you.
Right.
You come back from the movie hall
Right.
and you still think about it because the impression that was created, right?
Right.
If it is really good and you enjoyed it, I don't know you, but I want to share that joy. As, have you watched that movie? Have you watched that movie, right? Because you want to share that joy with others and let them experience
Right.
the creation, right? Innovation
Right.
that is there in the book, right?
Right. Right.
Same with books, right? So you can just see that. I hope you see where I'm heading to now.
Right.
So you play games because it is very,
Yeah.
you get joy out of it, enjoyable, right?
Right.
You read books because it resonates with your personality and you, whatever, right? You watch movies and you feel relaxed, refreshed, and it creates some long-lasting impression. Good movies, right? Bad movies, you go in half time, you are happy to leave.
Right.
Enough is enough because my time has more value, right?
Right.
It has happened, I'm sure, all of us, right?
Right.
So since you read books, I'll give you one more simple example, then I'll come to the point I'm making. Think about your school days. Have you read any book which is not in your textbook? That's a mystery book, thriller, novel, whatever is your passion, and hiding behind your textbook,
Yeah.
right? And telling your parents something different. They say, "Are you studying?" Yes. Your other book is hidden. We all have done it. If you have not done it, I'll be surprised. The question is again, who created that mood? Again, the author, right? You started reading a book, you can't do anything but finishing it.
Right.
Forget about sleeping, eating, because you are so mesmerized. It's a tight writing, the story,
Right.
expressions, right? Characters,
Right.
right? So my question would be, there is no difference between all of these things and writing your paper and doing research.
Right. Right.
Do you agree or not?
Right. Or even selling a business.
Absolutely, because it's the same thing. You are exhibiting your passion that brings you joy.
Right.
You are doing it because this is refreshing and relaxing.
Right.
It's because it resonates with my personality,
Right.
right? And you want everybody else to enjoy
Right.
the same way you enjoyed,
Right. Right.
right? And if you write papers with these simple facts in mind,
Right.
that I left that movie hall because it was not exciting. I threw away the book after reading first chapter because it was uninteresting. I did not play that's a football because that doesn't interest me.
Right.
So think about, you are now the author, you are the director, you are the actor, you are the player, right?
Right.
You are the storyteller,
Right.
and the receiving end of the reviewers and the readers.
Right.
Do they feel the same way?
Right.
Do they feel that, oh, I read this paper that
Right.
Stanley has written, is so exciting, so cool, and you say, oh, if you want to do something in program verification, read his paper first, right? So keep that in mind.
Right.
Then you exhibit. So if your emotions and passion should be embedded, that's what actually authors do, right? Authors and movie directors, actors, they put their emotions. You are moved with it,
Right.
and you think,
right.
oh, it could happen to me. It's my story,
Right. Right.
right?
Right.
Where they write it,
Right. Right. Right.
every reader who are avid readers and they're enjoying, they say, oh, it's my story.
Right.
Because it resonates very well with me and my personality, right?
Right.
So I think research is not different. The only thing is it is scientific.
Right.
It has to be provable.
Right.
You have to be able to repeat, because the science repeatability is the
Right.
key, right?
Right.
That means you do the experiments, I do the experiments under certain boundary conditions and environment. I should get the same,
Right.
right? Are you okay if you walk through this one? I'm in CBH, but there's an inside gate.
Oh, okay.
And if you do not know, today we'll be exploring that.
Yeah.
You can always go that way.
This we
This
didn't
makes
know.
half kilometer shorter, I believe. You can go through this thing inside. So, okay, what else? So what I'm saying that create an atmosphere, Germany before Second World War or Hitler's time was the epicenter of physics
Right.
and basic science and mathematics. If you read the stories, Max Planck, Max Bohr, all these people, and young scientists like Louis de Broglie, the wave particle duality, Heisenberg, uncertain difference. Every year, every PhD thesis will be a Nobel Prize. That's the way it used to be in 1920s. That US was not, because after the Hitler, many of the scientists came to US, and then US was rising, right?
Right.
Now, so their culture was just like that. Max Planck Institute. See, Max Planck Institute, of course, the computer science is there, physics also there.
Right.
MP, right?
Right.
So it should be just like that, because the whole environment is so conducive that you go there, you are charged.
Right.
Okay, so there in Göttingen used to have this lab, the Max Planck. Yeah, you can go through this. Yeah. So
High energy physics or something? No.
yeah. So lots of different things, right? And the quantum principles, quantum mechanics, all sorts of stuff, right? And so in the lab they'll have a board, right? A lot of students will come. It's more like a cafeteria style,
Okay.
right?
Okay.
So they'll go there, but everything is very creative thinking, right? So stories are just like that. So somebody will come. Let's say they're working on quantum theory, right? They did some derivations, theoretical physics or whatever.
Right.
And at 2:00 at night they left because they're very sleepy.
Right.
But they had strict instruction, the janitors,
Right,
or nobody can wipe out whatever is there on the board, right?
Right.
But they got stuck somewhere in between. 4:00 in the morning, another group of students came with a cup of coffee because they got up early, right?
Right.
They started looking at that and they tried to understand, started deriving from the rest.
Right.
So you can see that how the collaborative way they solve problems, right?
Right.
You do something, you get stuck, somebody else comes in, and creating an environment like that in the department, and you all can do it, right? And students, when they graduate, they'll have a long-lasting. I hope that you are not wasting your time.
No problem.
So, and if necessary, take the professor's help. Talk to your advisors, professors, and also the department. They can, encourage students. They put some, supply some food, this thing, that. I'm just saying.
Okay.
Food talks,
Right.
right? Always. This is very narrow.
Yeah.
This thing, of course, right? Very narrow. Only one person, very sequential algorithm.
Never seen this.
No, this is.
Okay.
This is just a shortcut.
Okay.
And we'll just go through this.
Okay. From there. Okay.
Yeah, no. Then we can actually. Yeah, you can go this way too, but there's an E gate on that side, right? But you can also go this way. So after a while, actually, you're
In Bell Road. Okay.
not the new Bell. Yeah, that will be on that side.
Okay.
But what is it? Janta supermarket.
Oh, right.
So which will be somewhere there, but
Okay.
we'll actually go this way.
Okay.
So basically, we'll bypass. Many of them go very close to D and E types of apartments.
Okay.
Then we actually bypass. It's, I think, probably close to 0.4 or 0.5 kilometers
Right.
or less, right?
Right.
Now, so I have talked a lot. So any other questions that you may have?
Right now, I think.
So execute your passion. That's the key part. And if that brings you joy and happiness,
Right.
you cannot buy that in supermarket.
Yeah,
right?
that is true.
You can, because that's an experience. You have to experience that, right? You experience it and also let others experience.
Right.
Help them experience, right?
Right.
You see, that is the EC.
Yes.
Then the
okay.
Janta Bazaar supermarket will be there.
Mm-hmm.
Right? So you have to experience it.
Right.
And those who have not done it, for example, let's say if somebody is in a party mood, right? So if we talk about the research, they have no meaning to that, right? They think, oh, you are full. Just come and have a drink and enjoy.
Right.
Because that's their world, right?
Right.
There's nothing wrong.
Yeah.
That's their priority.
Right.
But if you think that no, but that does not mean, see, your PhD student life is very precious, but at the same it should be enjoyable. That does not mean you don't socialize. That does not mean you don't play. You don't go to movies together or out. But you're mindful of your time.
Right.
Because you don't want to be in the PhD program for 10 years, right? Your time is valuable.
Right.
It's an investment on your time.
Right.
So if you're mindful of that, and enjoy what you are doing, then others will be inspired by association, because they see that you are enjoying it. Why can't I?
Right.
Some of them will be inspired. So what other obstacles did you face in your PhD life?
I have one. I'm not even.
No, you can be as open as possible. I'm not grading you. No grades, right?
It's a very I think it's something that almost everybody faces.
Right.
It's this insecurity that whether or not you'll be able to do PhD. You want to do, I want to do PhD. I don't think I'll.
Tell me, is there any security in our life? Anything? As I get married, there's no security that will be long lasting. I'm just giving a very practical example, right? Otherwise, there'll not be divorce cases. Or even if it is not divorce, but it's an unhappy marriage, right? So what I'm just giving a very simple one, right?
Right.
You go on the street and you knew somebody yesterday, you have seen him, today he got crashed on the car. So what I'm saying, the uncertainty is always there. But do I get scared with the uncertainty? That shouldn't be. No, I know how to tackle challenge. I'm not afraid of challenges. Whether I can finish it or not, that should be an outcome which is a byproduct. Let's say I'm in a course, game theory course this semester, right? From day one, if I think, can I get an A or not? Very counterproductive. You have not learned the subject yet, right? So I would say that put your efforts in doing what makes you happy and do your best, because you are the best judge. No matter how I say that I'm doing a lot of things, I'm spending time, you know in your conscience whether that is true or not. To the outside world, I can project. Oh, I'm spending 15 hours a day, but my professor is not happy, I'm not getting any results. Maybe true, may not be true, but in your conscience, you know exactly what is the truth, the ground truth, right? So I would suggest that don't step ahead, because you submit a paper, there's no guarantee it will be accepted.
Right.
It's no different than whether you can get there or not.
Right.
Because those who have submitted papers, all of us know
Right.
that we all get rejected. But should I back out? No. I fight back in a scientific way, intellectual way. Right?
Right.
Okay. What did I miss? What was the weakness? What was the flaw, right? So that I can improve and win the challenge next round. Right? So I know that we always tend to think ahead, but if you drop that idea, just do, then your outcome is a byproduct.
Right.
If I learn the subject very well, I can demonstrate, I understand the concept, there's no reason for me not to perform the very best in the class. Right? But if I don't do that and worry too much on the outcome, that kills the whole process of learning, because you're always worried about what if,
Right.
what if, right?
Right.
I know it is easier said than done, but I have practiced myself, right? Have you read, any of you have read any verses of Gita? I'll give you one verse, and you probably know it. Do you know this one verse? Very simple one. Karmanya dhikarestu Mahapalashu Kadachan. You know that, right? What does it mean?
I know it in English.
Yeah, in English, Hindi, whatever.
It's like, do whatever you have to do and don't wait for the result.
That's right. It's the same thing, right? It's not different from taking this course where I do whatever I need to do. That means I learn the subject, I do the homework, I understand the concept, right?
Right.
Don't wait for the result because I don't wait for the grade, but grade will come to me.
Right.
Right? Now, it should not be misinterpreted that since I don't know the outcome, why should I work hard?
Right.
That's a very wrong thinking.
Right. Right.
Right? Which one can misinterpret that way? Since I do not know the outcome,
Right.
why should I put effort now? That's not the way the world works, right? Because you think that in thermodynamics, right? There's a conservation of what? Energy, mass, and everything, right? So your input cannot be small and you expect a higher gain. It may work in a very transient, let's say a short term. Oh, before the exam I studied a lot, memorized, I did well. But that is not long lasting because the next course you take, you probably did not even know what they meant, right? The concepts. So there are tons of examples, but those I'm just saying that verse is similar to what you said. Like how did Rabindranath or your colleague asked, inspired, right? It's the same thing. That verse of Gita actually is very inspiring to me. You just do what you are supposed to do. Things will come, right?
Right.
But if I don't do in the very best possible way, how can I expect a better outcome? Right? So this is one. There are many other simple things. And another thing I have noticed, because having graduated so many PhD students, is you write an algorithm which is extremely efficient. Optimal in terms of time. I can prove the lower bound. Right? It takes the smallest amount of memory. It takes whatever, right? Or for the smartphone, you know how to optimize the battery, right? So that you're traveling and you can have a longer life of the smartphone, so you can communicate, right?
Right.
So we are basically making this device smart, your computer program very smart or efficient, right? Except what?
Simplicity.
No, I'm just saying you're making everybody else is very efficient, right? So my algorithm is very efficient. I have these graph algorithms, this algorithmic game theory. I can compute the strategies and the payoffs and all sorts of the equilibrium. I can prove that's the best you can do, right?
Right.
What I'm saying, you make all of this, but most often we do not manage our time to make ourselves very efficient. That's the tragedy, right? Because you are your best computer, your best algorithm, right?
Right.
And all sorts of things that you have, your computation, memory,
Right.
your bandwidth, how much you can learn or disseminate at one time, right? And your energy, which is your power or whatever, right? You just think about, if I optimize all of these things very well,
Right.
then your productivity, all these things will, is a processor utilization, right?
Right.
Network utilization, management of the time, all
Right.
these things. So keep those things in mind. So I wish I had an opportunity to meet with a larger body of the students maybe next time. That I wanted to get the feel
Right.
of what do the students think, right?
Right. Right.
And what you have, this dilemma is not uncommon. Those who have gone through the research career, we all have that,
Right.
because even for a new problem I encountered, I have the same frustration, right? Same disappointment, but you cannot give up, right? You may work on a problem for 6 months, 8 months, 12 months, you may not get any result. So what? You learned a lot through the process, right? You know ins and outs of the problem. Many things that did not work, you know that, right? See, when you read a paper, published paper, you do not know what did not work behind the scene, right?
Yeah. Yeah.
Right?
Right.
Nobody talks about it. They say, oh, this is what I have done. As if
Came overnight.
Out of the blue.
it did not come out of the blue. It's not overnight, right? So, because, you don't really report the failures. But these are very valuable, right? Because somebody should not take. But again, it's not universal, because just because I feel this way does not mean you'll feel that way.
Right.
Because you may be very thinking in the right direction, right?
Right.
And unless I go through this failure exercise and experience, just reading those has no meaning.
Right.
Because you'll not be able to appreciate
Right.
why did they approach that, because at that time you thought that is the best way to do it. But only to find out that no, it doesn't work.
Right.
But that's a very valuable lesson,
Right.
because I learned so much in between. I can make it work. So I'm sure all of you will be doing good, and I'm glad that you finished your masters, or you're still in the second year.
Second year.
Fantastic. Go for PhD. Encourage many of your classmates and colleagues. Right? They should be inspired. And you have good faculty members, right? And good
Right.
professors, but sometimes everything may not be latching with your interest. But you can always find problems which is
Right.
right. All right.
Okay.
So you walked all the way and you have to go back 2.2 kilometers again.
That's totally fine with me.
Right, yeah, okay. Anything else?
It was awesome.
Send me email, because you have all of my email address, right?
Yes, yes,
If
sure.
I could be of any help, send me email.
Sure, sure. I mean, thank you for your time. It was
No
amazing.
Good.
Everything was
No,
awesome.
no, you don't have to.
It's like
You
enjoyable.
you all are actually amazing, because I learned so many things. Okay?
Sure.
Okay, all right. Yeah.
Okay. See you.
Yeah.
Bye, sir.
Bye.
You want to?